Children, today in this lecture we will start our discussion from this statement. It is a very important statement according to which unique nature of zinc, lead and aluminium form oxides, example zinc oxide, and hydroxides, for example zinc hydroxides, which are amphoteric in nature. So what is the meaning of amphoteric nature? This means that these compounds can react with both bases and acids to give salt and water. Okay, students. So all these three metals are amphoteric. All these three elements are amphoteric. Their oxides of such types are amphoteric, and their hydroxides of such type are also amphoteric in nature, and these can react with both acids and bases to form salt and water. Okay, students. So if the question is example of amphoteric metals, then you will write any one metal accordingly. If the question is example of amphoteric element, then you can write any one of these. If amphoteric oxides are asked, then you can take any oxide of this metal. And for amphoteric hydroxide, you can write any hydroxide of these metals. Okay, students. So keep these all three metals, their oxide and hydroxides, in your mind for the example of amphoteric compounds and elements. The next heading is activity series of metals, reaction with water. So in this series which is given here, metals are placed on the basis of their reactivity from higher to lower. So towards the upper side, highly reactive metals are placed, and lower side, highly non-reactive metals are placed. So from potassium to iron, metals which are kept above hydrogen are reacting with water, but lead which is placed above to hydrogen is not reacting any form of water. Okay, students. So except lead, all metals which are kept above hydrogen are reacting with different forms of water, but lead is not reacting. Same way, the metals which are placed above hydrogen except lead. Okay, metals placed above hydrogen except lead have no reaction with dilute acids, but all other metals reacting with dilute acids and displacing hydrogen gas. Potassium reacts highly explosively with dilute acids. Sodium reacts less explosively with dilute acids. Calcium, magnesium, aluminium, zinc, iron react with decreasing vigor with dilute acids, liberating hydrogen. Okay, students. So this is the different type of nature of metals on the basis of their place in reactivity or activity series. The next page number 99, and here preparation of hydrogen, laboratory method. So as you can see in this diagram, for the laboratory method of hydrogen by action of dilute acid on zinc, so we use a flat bottom flask here, and in this flask we are having zinc granules. To add dilute HCl, we are using this thistle funnel, with the help of which we are adding here dilute HCl. So zinc reacts with dilute HCl according to this reaction forming hydrogen gas, and this hydrogen gas is passing through this passing tube and coming here. This is a trough which is filled with water and gas jar which is also filled with water. So hydrogen get collected in this gas jar by the downward displacement of water. Okay, so this portion of the gas jar is having hydrogen gas. Reaction is given here. Zinc when reacted with HCl forming zinc chloride and hydrogen. Reactants: granulated zinc in flat bottom flask X. Then dilute hydrochloric acid added through thistle funnel from here. Thistle funnel. Then procedure. Granulated zinc is placed in flat bottom flask and hydrochloric acid or dilute sulfuric acid is added slowly from the thistle funnel or dropping funnel. A brisk effervescence is seen with the evolution of hydrogen gas. So you will see a brisk effervescence here. These are the effervescence forming here when this HCl will be added in zinc granules. So brisk effervescence of hydrogen will form. Purification. Granulated zinc being impure on treatment with dilute HCl or H2SO4 evolves in traces gaseous impurities. So these impurities may be further removed by passage of the impure gas through 3 washer bottles and a U tube. So for the purification we are using 3 washer bottle and 1 AU tube. Okay students, so these washer bottle and U tubes are not shown in diagram. These are not shown in diagram. Okay. So according to this description, washer bottle 1 is containing silver nitrate solution which absorbs impurity of arsine AsH3 and phosphine PH3. Washer bottle 2 contains lead nitrate solution and this lead nitrate solution absorbs impurity of hydrogen sulfide gas H2S. Then washer bottle 3 contains KOH solution which absorbs impurity of NO2, CO2 and SO2 gas. U tube 4th contains anhydrous calcium chloride which absorbs moisture. So all 3 different bottles and this U tube are absorbing different type of gaseous impurities which are formed due to the impurity present in zinc granules, and these impurities are absorbed in the presence of different compounds accordingly. Then precautions. First point, no leakage of gas should take place and no flame must be near the apparatus. Why? Because we all know that hydrogen is highly inflammable gas. Okay students, so the area where we are preparing hydrogen gas, the area should be flame free area. No any type of flame should be near the apparatus for the formation of hydrogen gas, and no leakage should be there. Hydrogen is collected after all the air in the apparatus is allowed to escape. Pure hydrogen burns quietly in air, hence its purity can be tested. Okay students, so all the air of the gas jar should be removed before. Third point, the end of the thistle funnel should be dipped below the level of dilute acid in the flask X, or the hydrogen gas may escape out through the thistle funnel. So this last end of the thistle funnel should be dipped inside the dilute acid. If the last end will be here somewhere, then hydrogen will be formed, which will be formed here, can escape out from this passing tube also through the thistle funnel outside. Okay, so the last end of the thistle funnel should be dipped inside the dilute acid. Okay, so or you can say that much amount of dilute acid should be added here that this last end should be dipped inside the dilute acid. Then collection. Hydrogen gas is collected by the downward displacement of water. So here we are collecting hydrogen gas and it is collected by the downward displacement of water. The next page, preparation of hydrogen apparatus. In the above laboratory preparation of hydrogen, an airtight apparatus is used. Airtight. Hydrogen forms an explosive mixture with air, hence the complete apparatus is airtight, preventing any leakage of the gas. Second point, a naked flame should not be brought near the apparatus. Why? Because it may be cause of an explosion which may take place if the gas leaks. Third point, the lower end of the thistle funnel should dip below the level of the dilute acid in the flask, thereby minimizing the chances of any leakage of the hydrogen gas through the thistle funnel. The reactants, granulated zinc on reaction with dilute acid evolves hydrogen. So these two are the reactants. Granulated zinc is commercial zinc obtained from molten zinc. It may contain traces of impurities which has a slight catalyzing effect on the reaction. So this statement is very important. The impurities which are present in zinc are having slight catalyzing effect. Okay. Next point, addition of traces of copper 2 sulfate to the reaction medium also enhances the speed of the reaction. So copper 2 sulfate is also acting as a catalyst. The preferred acid is dilute hydrochloric acid or sulfuric acid. Nitric acid, being a strong oxidizing agent, oxidizes hydrogen formed to water, and that is why it is not used in the preparation of hydrogen gas in this method. Then collection of hydrogen. Hydrogen is collected by the downward displacement of water. First point, what is the reason of such type of collection of hydrogen? Hydrogen is almost insoluble in water, that is we are collecting it by the downward displacement of water. Second point, even though hydrogen is lighter than air, it is not collected by downward displacement of air. Why? Because it forms an explosive mixture with air. Pure dry hydrogen is collected over mercury or in a flask previously evacuated, thereby having absence of air. Then purification of hydrogen, again here given, hydrogen is purified by passage through different solutions. So granulated zinc on reaction with dilute acids imparts traces of gaseous impurities like phosphine, arsine, etc., which are removed by passage through different solutions. So as we have already discussed that arsine and phosphine are removed with the help of silver nitrate solution, hydrogen sulfide with the help of lead nitrate solution, nitrogen dioxide and carbon dioxide and sulfur dioxide with the help of potassium hydroxide solution, and moisture with the help of fused calcium chloride. Okay students, thank you.